Right. I'm throwing a lot at you right now, but you don't have to remember everything. You just have to remember a few things, okay? So we have primitive types. Right. And what I'm going to call this little segment is the implications. Implications of object. Also called reference. Reference types, okay? The implication. So we have primitive types, okay? Our primitive types are like int x equals 10, int y equals 15.0, whatever, right? Okay? And they're stored exactly in memory. Okay? And there's an interesting thing that happens here. And whoa, I almost fell over. Okay, so this is our memory, okay? And remember, our stack grows down and our heap grows up and all of that, okay? But what happens here? Well, we have x equal to 10, right? And we have y equal to 15. And this is in the Java's program, right? There might be Safari and other stuff here in the stack, but we're not going to worry about that right now. And then if I say int z equals 20, okay, then z equals 20, okay? Pretty good, all right? And then if I say z equals x plus 3 or something like that, okay? Well, what happens? Well, x evaluates to 10, right? And z, and then we add 3 to that, and so z is going to evaluate to 13, okay? Or I should just say, it's like this whole thing is replaced by 13. It's like saying z equals 13, okay? Similarly, I can also just say z equals x, right? And what will that do? Well, x will evaluate to 10, right? And so z will equal 10, okay? All right. So now let's try another one, okay? But let's do that with object types. Okay, and you might remember this. We did this exercise before, but if I say something like ball equals something, okay? And I give it a position, this is just, 10, 20, whatever, okay? I give it 6 numbers. I'm just not going to write them because I'm going to run out of space. And it's not super important. Oh, are you going to be, you're not going to be confused by it. No, this is good. My ball, another ball, just to make it clear, another ball, okay, equals new ball, whatever, and then we have, we invoke the constructor on it, okay? So my ball in memory equals 0x447, which points to some place on the heap, and it has all these values, okay? And another ball in memory has 0x552, and that points to another ball in memory. Okay, I mean a different ball in memory with different values, okay? So I'm going to write this nicer because I don't like how ugly I've written these. So my ball is 0x447, and another ball, which I'm going to call AB here, is 0x992 or something like that, okay? And they each have their own values. So this one's x position, for example, starts at 50. Well, this one's x position, for example, starts at 95, okay? Something like that, okay? And then they all have their own values after that, okay? All right, so we have this here, right? X equals 10, y equals 15, z equals 10, and then we say z equals 20, and then z equals x, and z will equal 10. Okay? We copy the value from x and give it to z. Okay? And actually, object types work the same way. All right? But the implications of that are a lot different. Why is that? Well, if I say my ball equals another ball, okay, what'll happen? Well, another ball evaluates to 0x992. So it's like we're saying my ball is now equal to 0x992. And that's like saying that both my ball and another ball are referencing the same exact ball in memory. So there's one ball and two variables each referencing the same ball. And what happens to this other ball? Well, nothing's referencing it. And so this gets what's called garbage collected. So if you've ever heard the term garbage collected or garbage collection, okay, and that's actually one of the nicest things about Java over one of some of our other lower level languages like C++, is this garbage collection of dynamic memory, okay, of this memory on the heap, okay? So if nothing's referencing an object on the heap, this is a ball object, right? And it used to be referenced by my ball until we did this, and then my ball's referencing a different ball now. Nothing's referencing this ball. It will be garbage collected. It'll be just, and all garbage collected means that it'll be released, and when it's released, it can be used for other variables because this is free store. So that we use that free space, and then it no longer is used, okay? And what is the implication of this now? Well, there are a few different implications of this, but the most important thing is that these two, so one thing is that this is called a shallow copy. Shallow copy. And why is it a shallow copy? Well, you didn't really copy one to the other like you did over here, right? Z is its own variable and X is its own variable, if I change X's value right here, it's only going to change X's value. But here, in reference world, my ball and another ball are referencing the same ball. So if I somehow change my ball, right, if I say my ball dot set position X to 34, all right, and then I print another ball dot get position X, and I know I'm not calling set position X right and get position X, but you guys have seen this like a million times. I'm sure you can kind of understand what I'm going with here. Okay, so what's going to happen? Well, my ball set position X is 34. My ball is referencing this ball object down here. Okay, and so what happens? Well, it's 34, so this is going to be changed to 34. Okay, and then we're going to print out another ball's get position X. Okay, and we come down here, and what's going to be printed out? 34. So another ball got changed because my ball changed it. So two different references pointing to the same object means they can both change the object. Okay, and so that's the implication of all of this. The implication is this idea of we can have a shallow copy. Okay, so some of you might be thinking, well, what's a way we can have a deep copy? And there's a few ways we can do it, but we're going to do it. I'll tell you how we might do it in this situation using ideas we already know, right? And it's actually not that bad. All we would do is we would say, well, I want if I want my ball to have the same values as another ball, but be its own object, I could just say my ball equals new ball. And then for the X position, I might say another ball dot get X pos or whatever, right? And then I do the same thing for Y pos, and I do the same thing for X velocity and Y velocity and all of those things, okay? And in that case, what will happen is my ball will create a new ball here on the heap, but its X pos will be the same value, will be initialized to the same value as another ball's X pos, right? And its Y pos will be initialized to the same value as another ball's Y pos. But now I can modify my ball and it won't modify the other ball, okay? So that's how references work. Two different ball references can reference the same ball object in memory, and it's actually kind of easy to do, right? We just kind of did it here. So that's the implications of this. And so what does that mean in terms of how we use objects and how we use primitives? Well, we'll get into that. It's actually kind of a nice, this shallow copy thing comes into play and works to our advantage in some situations. And when it doesn't work to our advantage, we can just end up basically, there's a method called clone which basically does this in Java. So I'll show you that method later. But you're basically just, you can create one that's a copy of another pretty easily. Just the ways we've normally, using methods, the constructor that we know how to use, okay? So that's all you got to remember about reference types. They're just referencing memory, and if you set them equal to each other, both things are going to be referencing the same object. And if you remember that, you're golden for the next thing we're going to talk about, which is linked lists, okay? See you next video.